We have on the board a diagram of a network where each of these nodes represents a router. And we're going to try to find the shortest path from node U to all the other nodes in the network. Now, we see that node U is directly connected to three other nodes, X, W, and V. And as you notice these links between all the nodes, there's a number, and that number is the cost or the distance between those nodes. We're going to put down a tentative distance to each of the nodes based upon what we know right now. The first thing is, for the directly connected nodes, X, W, and V, we know the cost right away. We can just look at the chart and see. Tentative distance to X is 5. The tentative distance to W is 3. And the tentative distance to V is 7. But we don't know anything about Y and Z yet. So we're going to put down the tentative distance of infinity for these. We're starting from node U, the source node. And we're going to put that down that we already have visited that node. Our next step is to take a look at the shortest or the closest node to U. And we notice that that is 3. So we're going to take an educated guess here. And we're going to say that probably the shortest path to most of the nodes is through node W. We're going to visit node W, and we're going to call this the current node. And we're going to examine the distance from U going through W to all the other nodes. First, we take a look and see going to X from W, the cost would be 3 plus 4, or 7, versus the directly connected path of 5. So we'll take the original cost in the original path, and this is the cost of 5 going through U, directly connection. Now how about node V? In node V, going through W, the cost is 3 plus 3, or 6. That is cheaper than the tentative distance already put down. So we will change the tentative distance to 6. And we'll mark down that we visited W, but we still have a little bit more work to do with W because W is connected to Y. As we see, the cost of going from U to Y through W is now 11. So we know more than we knew before, so we can erase the infinity and put down the tentative cost to Y as 11, going through W. And right here, for V, I need to put down that we were going through W. So at the moment, what have we checked out? We visited 2 nodes, and we've checked out these links so far. So now let's go to another node. The other node is X. X is now connected to Y and Z. We haven't visited those nodes nor these links. So we're going to start by saying now we're visiting X, and the cost to get from U to Y through X is 5 plus 7, 12. That 12 is not smaller than the 11 that's already there. So we're going to keep the 11 for the distance, tentative distance to Y. Next, we're going to check out the distance to Z going through X. The cost is 5 plus 9, which is certainly less than our original statement of infinity. So with our notation, the cost to get from U to Z is 14 by going through node X. Next, we're going to visit V. We haven't visited that yet. By the way, I'm checking off the paths from X that we just explored. So the unexplored path from V is V to Y. By going through V, the cost to Y is 11. It's the same as the cost by going through W. So we don't need to change anything. Oh, wait a minute, we have a check. We got a problem here. We haven't checked one thing. We haven't checked the path by going from U to W to V to Y. If we take a look here, U to W is 3, W to V is 3, and V to Y is 4. That's a total of 10. That's now a new shortest distance by going through V. And we have now visited V. So let's go now to a new current node, one we haven't visited yet, which is Y. And let's see what we have where we haven't gone before, and that's Y to Z. So from U to Z through V, Y, and to Z would be a total of 7 plus 4 plus 2, or 13. But if we went from U to W to V to Y to Z, the total is 3 plus 3 plus 4 plus 2, which is 12. So we've now visited every node, and now we have the costs between the source and every node. So let's now take out all the lines, all the connections that aren't the lowest cost. We're going to find the shortest path to everything, and I'm going to draw this on the board. And I'll emphasize this. This is our diagram of the shortest path to every node.